Hello everyone, and welcome back to Planetary Possibilities. I'm Aria, and if you're new here, this is the channel where we dive deep into the most mind-bending worlds that could actually exist out there in the cosmos. Are you ready for this? Scientists think it might literally rain diamonds on Neptune and Uranus. Like, actual diamonds, falling through the atmosphere, right now. So, if diamond rain is possible in our own solar system, what about worlds where this isn't just a maybe, but the entire planet's defining feature? What would those worlds actually look like? Well, that's exactly what we're exploring today, because we're kicking off a brand new mini-series about the absolute craziest planets that science says are possible. Over the next few weeks, we're going to worlds where diamonds literally fall from the sky, planets that stare back at you like massive cosmic eyeballs, mirror worlds so reflective they could blind you from billions of miles away, and rogue electric planets crackling with perpetual lightning storms as they drift through the darkness between stars. Today, we're starting with diamond rain worlds, because honestly, what's more mind-blowing than weather that would make you the richest person on Earth just by stepping outside? Okay, let's get the science straight first, because understanding how diamonds can literally fall from the sky is going to make everything else we talk about so much cooler. Diamond rain happens when you have three key ingredients: carbon, crushing pressure, and intense heat. On Earth, diamonds form deep in our planet's mantle, where the pressure is about 50,000 times greater than at sea level, and temperatures reach over 1,000 degrees Celsius. But here's the thing. You don't need to be deep underground for this to happen. You see, in the atmospheres of gas giants, these conditions exist naturally. Neptune and Uranus have atmospheres rich in methane, that's CH4, carbon and hydrogen. When lightning strikes in these atmospheres, and I'm talking about lightning that makes our storms look like birthday candles, it can break apart those methane molecules. The carbon gets compressed by the immense atmospheric pressure, and boom, you've got diamond formation, thousands of kilometers above any surface. In 2017, scientists at Stanford actually recreated this process in a lab. They used shock waves to compress hydrocarbon materials and watched diamonds form in real time. They proved that diamond rain isn't just possible. On worlds with the right conditions, it's inevitable. But Neptune and Uranus are just the appetizer. Let's imagine three types of worlds where diamond rain isn't an occasional phenomenon. It's the defining feature of the entire planet. Welcome to our first world. Let's call it Adamantia. Now, picture this, what it looks like. You're orbiting a planet that looks like a massive jewel spinning in space. The upper atmosphere is a roiling mass of dark carbon clouds, shot through with constant lightning that illuminates the storms from within like a cosmic light show. But it's what's falling from those clouds that takes your breath away. Diamond rain falls continuously across 70% of the planet's surface. Not tiny diamonds. We're talking about gems the size of raindrops, hailstones, even golf balls in the most intense storms. From orbit, you can actually see the glint of falling diamonds catching the light of the system's star, creating shimmering curtains that sweep across entire continents. How it works? Adamantia orbits very close to its star, close enough that the intense radiation continuously splits carbon dioxide and methane in its thick atmosphere. The planet's rapid rotation, once every 8 hours, creates massive Coriolis forces that generate perpetual storm systems. These storms create pressure differentials that are perfect diamond factories. Carbon gets compressed in the downdrafts, forms diamonds, and falls through the less dense lower atmosphere. Why it's scientifically possible? This kind of world could form around carbon-rich stars, where the original planetary disk had way more carbon than our solar system. We've already found carbon-rich exoplanets, planets that are essentially massive diamonds with thin atmospheres. Scale that up, add a thick atmosphere and stellar radiation, and you get Adamantia. The surface of this world would be indescribable. Imagine landscapes covered not in snow or sand, but in accumulated diamonds, some the size of boulders, creating crystal formations that stretch to the horizon. But what about a world where the diamond rain has been falling for millions of years? Meet Crystallos, what it looks like. If Adamantia is a jewel, Crystallos is a treasure chest that's been left open for eons. The diamond storms here happen seasonally, tied to the planet's highly elliptical orbit. When it swings close to its binary star system, the diamond rain begins. When it swings away, the rain stops, leaving behind the accumulated wealth of geological ages. Picture vast crystalline deserts where diamond dunes shift in alien winds. Mountain ranges made entirely of compressed diamond formations, created by millions of years of accumulated precipitation. In some regions, the diamonds have fused together under their own weight, creating crystal caves and tunnels that stretch for kilometers underground. How it works. Crystallos has a 40-year orbit, and the diamond rain only happens during its 5-year close approach to its stars. The planet's thin atmosphere means the diamonds fall fast and hit hard, but they don't blow away because there's not enough wind. Instead, they accumulate layer upon layer, creating stratified deposits that tell the story of millions of orbital cycles. Why it's scientifically possible? Elliptical orbits are common, especially in binary star systems. The varying stellar radiation would absolutely create this kind of seasonal diamond rain, and we know that diamonds can survive for millions of years under the right conditions. Earth's diamonds are often billions of years old. Here's the crazy part. If you could somehow walk on Crystallos during its quiet period, your footsteps would literally crunch through diamonds. You'd be walking on the most valuable surface in the known universe. Now for our third and most incredible world, one that pushes the boundaries of what's possible. We'll call it Vitrolux. What it looks like, Vitrolux doesn't just have diamond rain, it has diamond weather systems. The planet's unique magnetic field and atmospheric composition create different types of diamond precipitation in different regions. Near the poles, tiny diamond snow falls gently, creating glittering white landscapes. Around the equator, diamond thunderstorms rage, with lightning that actually forms diamonds in real time as you watch. But here's the kicker. The planet has regions where the diamonds are forming in organized patterns, crystalline structures that look almost designed. We're talking about natural diamond formations that create geometric patterns visible from space. How it works. Vitrolux has something no other planet we've imagined has. A powerful, organized magnetic field that actually influences how the diamonds form and fall. The magnetic field lines create channels in the atmosphere where diamond formation is more likely, leading to those organized patterns. The planet also has a complex atmospheric chemistry with multiple carbon compounds, creating different types of diamond rain, some clear, some colored, some with different crystal structures. Why it's scientifically possible? We know magnetic fields can influence charged particles in atmospheres. That's how we get auroras on Earth. If the diamond formation process involves ionized carbon, then a strong magnetic field absolutely could create organized patterns. And complex atmospheric chemistry? We found planets with dozens of different compounds in their atmospheres. Vitrolux just takes it to the extreme. The really wild thing is that over geological time, these organized diamond formations could create natural crystal sculptures on a planetary scale. Art created by physics, visible from space. Now, I know what some of you are thinking. This sounds amazing, but how realistic is any of this? And that's a fair question. Diamond rain on Neptune and Uranus? That's not just possible, it's probable. The 2017 Stanford experiments proved the basic mechanism works. As for our 3 imaginary worlds, well, they push the boundaries, but they don't break the laws of physics. We've already discovered over 5,000 exoplanets, and they're way weirder than anyone expected. There's a planet made of burning ice, planets where it rains liquid glass sideways, a planet so dark it absorbs 99% of light that hits it. If those can exist, why not diamond rain worlds? The universe has had 13.8 billion years to get creative with planetary formation, and it's produced things that would have sounded like pure fantasy just decades ago. Diamond rain worlds might sound impossible, but in a universe with billions of galaxies, each containing billions of stars, I'd bet money that somewhere out there it's raining diamonds right now. So that's our deep dive into diamond rain worlds. From the very real possibility in our own solar system to the wildest extremes that physics might allow. Personally, I can't stop thinking about what it would be like to experience weather that would make you the richest person on Earth just by standing outside for 5 minutes. This is just the first episode in our new series about the craziest possible planets. Next week, we're exploring mirror worlds planets with such reflective surfaces that they could blind you from 1 billion miles away. And after that, well, let's just say we're going to visit places where the laws of physics get creative. If you enjoyed this journey to the diamond rain worlds, definitely hit that subscribe button because we're just getting started with the weird and wonderful possibilities out there. Drop a comment and let me know, if you could visit one of these diamond worlds, which would you choose? Personally, I think I'd go with Crystallos during its quiet period. Walking on diamond sand sounds like the ultimate otherworldly experience. Thanks for exploring the cosmos with me today. I'm Aria, this has been Planetary Possibilities, and I'll see you next week for another journey to the impossible worlds that just might be possible after all.